Okay, I think we're core 8, or whatever it is, for a plenary. Thank you very much for coming and coming to this plenary. I'm delighted to be able to introduce Dr. Betty Schmeister, who is Head of Data Science at Money Supermarket. Betty's had an impressive and fast, accelerated career thus far, and I want to just give you a few words just so you get an impression of what an impressive person she is. So in 2012, she completed her PhD in evolutionary genetics at the University of Zurich, and then across several projects at the University of Bristol, moved into bioinformatics and evolutionary biology. She then joined Royal Mail data science team, which is where I met her, in 2016, and worked on many projects across the sort of data science know space, and forecasting and revenue prediction, absence prediction, A/B testing, mail traffic forecasting, lots of high quality projects that really were focused on delivering outcomes and value and results, which is, after all, what we're trying to achieve. So yes, I mean, and then from there, she became head of data science at Royal Mail, and has subsequently moved to Money Supermarket just this year, and has been in post only 3 months. But first and foremost, she's an absolutely lovely person and a really talented data scientist. And today she's going to give us some interesting stories, I think, from the coalface and her experience thus far with Money Supermarket. So thank you so much, Betty, for coming and giving us a plenary today, and I'll hand over to you.
Thank you very much, Jeremy, for inviting me. It has been a really interesting day. I've already seen some talks of you. It's fantastic to be here, so thank you very much. And I'm looking forward to the sessions after this. I think there's applied AI. I'm going to go to that one. So I'm going to talk today about what I did at Money Supermarket so far. I only joined 3 months ago. This doesn't work, sorry. It's disconnected, so I always have to walk back and forth. Thanks for introducing me, Jeremy. I nevertheless put this slide up. I knew you had a really nice introduction, but just to pick up on this. So before I joined Royal Mail, I worked with data to discover how cyanobacteria evolved, the origin of life, how our planet became oxygenated. And that sounds really interesting. But at some point, I decided to move on to a business context. So I moved to London, joined Royal Mail, and utilized their data to see how can I support their business, what they're doing. Among other projects, the revenue prediction, you mentioned mail forecast, engagement prediction, but also the estimated delivery window. I mentioned this one because, funny enough, I've been here a few years ago presenting the project at this meeting. And I also published about this project in the Impact Journal, so if you want to have a look. So the estimated delivery window is basically when you have when Royal Mail sends you a text and says your parcel will arrive between 10 and 12, then that's the algorithm that we built, that's deployed at Royal Mail, running live in production. And this is now 3 months ago, I moved to Money Supermarket. I've been involved in several projects already, so I will present some of them here. We have loads of projects lined up. And I thought with this move, I wanted to describe a bit how you get projects into production. So at this point, my question to you would be, how many of you have worked actively on data science projects? Raise your hand. A few, yes, good. And how many of you have seen their projects run live in production in a company? A bit fewer, but still some hands, which is great. So I've been involved in several projects at Royal Mail and now at Money Supermarket that run in production. And I thought, and as we move on, I thought it would be good to talk about how we can utilize cloud-based MLOps techniques to get projects in production and have them running for years to be maintained, to be scalable. Now, I was very bold with my title. I said ML Ops in Action, which when I joined Money Supermarket, I was like, yeah, I have a plan. We get this through really quickly. I have slightly adjusted the title, so I have to back and forth, to MLOps in progress. Why in progress? It's not as bad as it sounds. So the MLOps, we have a pipeline, but it's not the one that we want just yet. So it's still a work in progress, so to speak. I will structure this talk into two parts. So first I will talk a bit about MLOps, why people use MLOps nowadays, and then move to Money Supermarket and the products we're working on there. So just to go a bit back, data science, when did it originate? When did we hear the first time data science? So there is a paper from William S. Cleveland where he talks about data science and action plan for expanding the technical areas of the field of statistics. So Cleveland, he's a professor working on data science problems. So he saw the need for a lot of companies. They have statisticians, and they have, back in the day, so that's 2001, they have statisticians and they have computer scientists, but there's a bit, they don't match together. So the statisticians, they don't have the tools to utilize the data that were growing and growing, becoming more and more. Whereas the computer scientists, they lack the statistical knowledge they could handle the data, but they couldn't really do something that would benefit the business with the data. So he is suggesting an action plan how you could implement a program at a university to teach students data science, so to utilize statistics and computer science. Shortly afterwards, there's several, we have journals launching, the Data Science Journal, which is focusing on data and databases, but then shortly after 2002, there's another one called, let me get this right, so this is the Data Science Journal, and then we have the Journal of Data Science, which is focusing on everything data related. So very similar names, but you see the need that people suddenly had for understanding data science a bit better and what can we do with it. So, and then moving forward in time, 2010, we have Drew Conway, the founder of Alluvium, a New York-based company, drawing this data science Venn diagram. And shortly after, we have the mentioning of data science as the sexiest job of the 21st century. I think many people have heard that, that phrase from the Harvard Business Review. So if we look at Conway's Venn diagram, so he describes this has been used in various times and changed and adapted. So I thought it's nice to just have a look how he defines or how he sees data science. And it's those three areas where we have hacking skills. Back then it was hacking skills and maths and stats and the substance experts, so the business people or the business knowledge. And if you merge those together, you get data science in the middle. So this forms the foundation for data science. And as you might have noticed, there's this little danger zone, which is people that have a lot of business knowledge and know some hacking and can do something quickly, come to a solution. And I think one of the most dangerous things is this correlation doesn't mean causation. Everybody heard it, but people still, it still happens. So where are we now today? So today, the hacking thing, I think, this has to be rephrased, and we're moving more towards a coding DevOps field where now you really need not just hacking skills, but proper computer science skills and deployment skills, DevOps skills, to get something into production and have it running with, millions of data points, running daily, maybe in real time, and it needs to be supported, it needs to be running. You can't have a data scientist just hacking around in a notebook, and this will then support big businesses. So there has been a change in thinking to efficiently build and release code changes and monitor systems. Now, if we look at the tool set, how the tool set evolved over time, we see that we have in 2005, as data grow, we get the Hadoop framework, which now helps you to manage big data with the MapReduce algorithm that they have, that was published a year before by Google. Hadoop, people might have seen the little tiny cute elephant. So it was named after the person, I think his name is Cutting. Yeah, who developed Hadoop. He named it after he had this little elephant as a logo after his child's toy, which is quite cute, so you remember easily. At the same time, we have Git developing, so here is version control starting, you start working better in teams and collaborating. And then from 2010 onwards, we see that suddenly we need more tools to process and store this data. So we get BigQuery in 2010, a compute engine. Obviously, it's not just Google, it's Amazon and Microsoft. Everybody's working on how can we handle all these data points that we suddenly have. And then up to recently, we see Google's Vertex AI and feature stores that have been deployed. And to go back to Tom Davenport and the Harvard Business Review, so they published did I mention it? No, I didn't mention it. So they published an update, is data science still the sexiest job in the 21st century? Which I thought was interesting, nice to catch up on this. And they say it's now changed a bit. So whereas, although you have all these cloud-based developments, so we see here from 2010, suddenly everything moves towards the cloud, cloud-based processing, data storage, increasing emphasis on monitoring model as you deploy more and more data science models. But nevertheless, they find that people still struggle to get something running in production, that you still have data scientists being busy cleaning data, transforming data, mining data, 70% of their time almost often at many companies. And and they come to the conclusion, they say, if you look at LinkedIn, there's job titles looked for AI communicator, product owner, AI product deliverer, loads of new names, new job roles that come up because you have the data science, you have the algorithms that are built, but they never get deployed, they never run in production, they never come to the potential that they could have, so the businesses never really get the full value. I'm saying it as if everybody's like that. Of course, there are things deployed and things are moving forward, but not at the pace not at the pace we would have anticipated a few years ago. So so the question is, so I thought, because I talked about my title and I said MLOps in action, and it's maybe MLOps in progress. So I thought, I'm 3 months into the new job. Maybe I'll talk about some challenges that we're facing as we're deploying things, and why would you need MLOps? Why this need for all these cloud tools that help you to make things easier and push things forward? And how can you avoid your data scientists being stuck in endless, finding data, cleaning data, and transforming data? So if we go back and look at the typical data science workflow, so you start off here with a business objective. So this is just an example. I mean, there might be variations of, you might have a slightly different project cycle. But I think we agree you start off with a business problem, business objectives. This could be a full talk in itself, I mentioned earlier to Jeremy, because it's the whole stakeholder management. How do you get them engaged? How do you find out what is the real problem of the business? Where are they losing money? Where do they need value? How will your product be implemented in their workflows? How will they use your results? Moving from there, so building this relationship with stakeholders, you move over to research and data exploration. So do you have the data available that you need? Can you build a POC? Can you run a quick model that could answer the question that the business has? Do some literature research. What sort of techniques are out there? How could you improve it? Is your data set skewed? Do you have problems in predicting something that makes sense? Which leads you, so to the data processing. Next step, where you might find, actually, we have a skewed data sample, or the data is not as clean as we hope. We need to clean outliers, those sort of things. So you start some transformation process, some pre-processing of your data that you have to then store and sort of like process somewhere. Then you go to the data modeling. So this is the part where everybody sees data science. And this is the thing everybody wants to do, right? So everybody's waiting for the point, when can I finally model something? When can I experiment and try different things? So, but as you see here, it's just one step in this huge pipeline. Following the data modeling training, you need an evaluation metrics. Ideally, the business would understand what you're evaluating. So they would understand what you're presenting to them, and they could make a decision: when is your model good enough? When can they use it, to deploy it? When would it make sense for the business? If you don't come to the point, you start all over again, asking more questions, getting more data, doing more research, more processing, and so forth. So it's an iterative process that will go on and can go on for a long time. Ideally, you would focus on an MVP though, so something simple that you can build for the business that they see fit to use in production. And then you would go over to try to serve that model. So how can we deploy it now? Can we have it live in production? And how will we continue to monitor that model so that we see if there's anything occurring down the pipeline, data drift, the data changing, the business objective is changing, they want to scale it up. How can we monitor and make sure that our performance is still what we had promised originally? And on this way, it looks all great and nice and neat, but obviously there's several things that can happen. So I mentioned, you start with data exploration. The first issue you can get is access to data. So I have had that a lot in my career. So you start off and then, oh, you don't have permission to use this data. Oh, the data are not there, they are on a local machine. Oh, they're in a different database. So, the data might not be accessible. Once you have the data, you might notice, oh, they are not what I was told they are. They are not as clean as I thought. Somebody might have had them on their local machine and changed them manually. Those sort of things that can happen in a big business where people might have easy access to data and can just, might not follow the best protocol, maybe, send data or, So it happens. It always happens at some point. The next thing you need to watch out for, and this is your own doing, is make sure your ways of working are good and consistent, and you build something that's actually maintainable for a long time. So this is around data scientists attempted into, and it's good. I mean, that's the curiosity, and we want to, explore data and find out what do we find in there and do it quickly and get the next result and push forward. But what can happen is that you build complex, unreadable code. So a monolith of code, a long monolith of code with loads of conditionals, with loads of, where you and it grows over time. And if you don't start to refactor or build in tests or document, you will end up with a product that you can't deploy as is. So if you finally got the results you actually wanted, you might be stuck and you have to go back and start, okay, how can I deploy this now? How can we run this in production? So make sure that you implement tests, that you have documentation, that you refactor, that your code is functional. So tests, I mean unit tests. If you put little code snippets and functions, you can unit test them. Don't make the functions too big, those sort of things. Why tests? Why unit tests? So unit tests, they test single pieces of code. So a unit test should test one unit of your code. Why do you put unit tests? It has also to do with if somebody takes over your work, you might move on, you build something for a business, and then you find a better job or another job, and you move on, and you leave this project behind. Somebody new joining, they need to find their way into your code. So if they have unit tests, they can easily go through your code and find, understand what you're doing. Make sure if they implement changes, it's all still working. And finally, once you come to the point where you want to serve a model and have it running, you need to make sure that you don't have data leakage is something that can occur, where people train a model with data they do not have in real time. So it shouldn't occur, but it can always occur. If you have a lot of features, one might sneak in. I read something where somebody said, if your model looks too good, then probably it's too good. So always check for accuracy. If it's too good to be true, then maybe it is not true. The time to run, you might find out, did you really understand when the business does need this product? You need to make sure that you can deliver it in time. So, for example, if they have a process that's running every morning, can you deliver that model or that with the latest data in the morning at 8 a.m. or something? So those sort of things. So how long does it take to run? Do you have any resource challenges? If you work with other teams, that's always an issue. Do you need someone else who helps you to deploy this? How do they have time? Is it on their priority list? Do you talk to them beforehand? Once you have a model deployed, there's more issues to come. I'm sorry, it's a lot of issues. We'll find a solution later on, but you have to think about, so this is just an example from a book I've read, this Introducing MLOps. But you often have, it's not just a data science team, but it's various teams that help you deploy something and run in production. So there will be, the business people, there might be analysts, there might be data engineers, there might be DevOps engineers, there might be ML engineers, there are various teams that work together to get something in production and finally running in a business. And this is only for one model. Now imagine you have something running, but then you have another product that you want to deliver. Suddenly you have 2 projects. And it goes up and up, how scalable is what you've built? How reproducible? Can you use a similar template for similar projects? How can you manage risks once something is automated and used for decision-making in the business? How can you prevent things like, data changes affecting your output? We had a pipeline that we built where we predicted something and data changed downstream. We hadn't even noticed. And then, the output was changing. And suddenly the business noticed because they were like, oh, what's happening? This is not what we asked for, and this is not doing what it's supposed to do. So you have to be able to manage that risk. Again, tests can be really useful, as I mentioned earlier, on modularizing your code, not just having a code block or a notebook, but build code. Get the data engineering skills you need as a data scientist to sort of improve your code. And with all these dependencies of different teams, it becomes constantly challenging because not only do you have a high turnover in data science, where people might only stay 2 years at a company and move on because they're not happy with their work or they do too much data cleaning. But additionally, data engineers might move on. So people who worked on the original product might move on. And then suddenly, if anything happens into a project in production, the business can't use it anymore. So it happens to the nicest products where you think you build something really great, and then suddenly 2 years down the line, you see it's not used anymore because it just broke at some point, nobody could fix it. Oh, and another point I wanted to mention, cross-functional communication. I came across that recently. So where, different teams you think the same language, but they don't. So things like performance, where I talk performance of a model, a data engineer might talk performance of the whole end-to-end pipeline, so the time it needs to run, or features that might mean different things to different teams, or even model. I saw that, with the DBT tool, you build SQL models. They call them model. I thought they built a model, an algorithm. They don't. So those are all on, and trust between teams, obviously, this is a big one. So coming to an end here with the first part of my talk. So you see all these challenges and all these difficulties you have in getting things actually running live in production and keep them running for years. You come to a point where MLOps might be just what you need, or might be just make it a bit easier for you. I'm going to tell you this. I'm going to tell you why. But first, let's focus on what we're doing at MoneySuperMarket. So you saw my title, and there was a second part to it. That was the connect with your customer. So MoneySuperMarket, we have, obviously, we're a pricing comparison website. So we deal directly with customers. And part of what we do is we want to make the journey for the customer as easy as possible. So we want to follow the customer from getting their attention, using a marketing mix model, to creating an incentive with pricing investments, and facilitating their journey with a quick estimate and keeping them engaged with product relevance. I'm going to talk more about that in a second, just moving back. So MoneySuperMarket. How many people have heard of MoneySuperMarket? I hope everyone. Some people are not raising their hands, so I'm like, what? Okay, no, it's a pricing comparison website. It was originally founded by Simon Nixon and Duncan Cameron, where they wanted to build a mortgage. They built a mortgage subscription in 1987. So really just where people, could get a magazine where they had mortgage recommendations for them, for brokers. And it got so successful that they switched. Okay, when the internet came along, they were like, oh, we'll make a website. They made loads of money. It grew really quickly, and it became this tool easy tool to just compare prices among different providers. Originally mortgages, but they moved on to loads of different channels. You might have heard the advertising. We had the Haggle Hero back in the days. There was a comedian, a British comedian, then Skeletor. So they had quite funny advertisements. Also, sometimes advertisements people didn't like too much. Today, we have different channels that we're supporting. So car, home, life, mortgage, broadband, mobile, travel, loads of them. MoneySuperMarket also bought several other companies. It's worth pointing out Money Saving Expert. I pointed out because it's a different, you know, Martin Lewis is often on the news, particularly now as the crisis is hitting. And I just want to point out, so even though it belongs to Money Supermarket, it's completely separate. So the editorial is by no means influenced by Money Supermarket, which is good to know because they try to give, you know, advice, amongst other advice on pricing comparison websites. So other things we bought recently, Quidco is a cashback site, and Travel Supermarket. And this is our latest campaign, how can we save £1 billion, so this Money Super 7. So and obviously moving forward, so one of the challenges Money Supermarket has is its competitors, right? So it's obviously not the only pricing comparison website. There's loads of them out there. So these are the most common ones. Everybody's seen the Meerkat and Go Compare. So good advertisements, yeah. So, but to keep up with our challenges, so with the competition, data science comes in. And here data science can develop different models to support the business, to find, you know, to facilitate the customer journey, make it easier for the customer to move through our platform. One of the models, so the first one, we do marketing mix modeling. So this is marketing mix modeling has been around for a while. So we are applying Bayesian inference here to, you know, it's just meant to, how can we use regression models to estimate what is the return of investment. So for the data that we spend to different media, this is above the line, so TV, news, out of home, or below the line, which would be social, digital things. So how can we optimize our spend across those media to get the most return? It's a great project for data science. So we have that running live. Another one we have running live is pricing investment. So you might see, if you go to a pricing comparison website, you can see sometimes they're a bit different. So you might have, for example, here, you have Hastings on position 3. Now, if we applied a pricing investment, so if we reduced the price, we could move Hastings up, and then you know, basically speak to them. If you went off your price a bit, then we could move you in the position, and this would benefit you, would get more sales or more customers. So the way we do this is we build a dashboard for them where the product team, they can play around and try different investments and see. The next step is to optimize those investments or to look at different segments. How can we identify segments in our data set to say, where is it, you know, where should we invest more or where should we invest differently to push this forward? Another one we're doing, this is facilitating the journey as you are on our website, would be looking at, if you go through an inquiry form, they can often be long and tedious. So what we try to do is, can we find the most important data points? So for example, if you apply for a quote with a provider for your car insurance, you will give information around which car are you driving, what is your transmission, how long have you been driving, do you have any claims, maybe some personal information, where do you live, do you own a home, those sort of things, rural or cities. Can we reduce that data set to make it easier for you? Do we need all that information, or can we predict what we think your estimate will be, your quote will be, if we just reduce the data points that we're using? So that's something we're working on. And finally, this is the last one. I put the picture up, so this is keeping you engaged. This is around product recommendation. I like the pictures of things to have in the Atpath. I took it from him. But it's just, if you look at those two customers, so they just assume they are customers just assume they were customers. They're both born in 1984. They grew up in England. They're married twice. They have children. They're successful and rich, take vacation in the Alps, and they like dogs. Would you recommend, or would you approach them in the same way? Would you send them the same messages via email or on a website? Maybe not. And this is, so this goes beyond, you know, where companies might just use a few features that they have from a customer and try to build a very basic decision on how they recommend things. We jump in and we say, why don't we take machine learning and just build something based on thousands of features that we have from our customers? And we can have millions, so we have over 10 million customers. And if we utilize all those features, we can maybe build something that makes more sense to them, or is more, you know, that they can engage with better. That brings me to the MLOps pipeline, so now we're there. So you saw these different products, and there's obviously, they require different, techniques, different people are involved for the MMM model, the marketing mix modeling. We have an econometrician that's involved. So people with different skill sets come together and work on those projects and deploy them somewhere. And then they might move on, they might leave the company, they might not be there anymore. And suddenly you have this problem of you have these tools that are working great for the company, but as soon as people leave, they break down. Something occurs, data change, they need to do a code change, just something tiny and might break the whole pipeline. So MLOps can be of great support. Why? Because suddenly it helps you to keep some of those, to utilize some of those engineering tactics or best ways of working that will make it easier to maintain a model in the long run, to maintain a product in the long run for a company. So we tried to come up with a template that we can reutilize across different products, different data science products. So this starts with a data lake, moves into a BigQuery, so a database, and then over to reutilize DBT. That's a data build tool, which is utilized for data transformation and quality testing. And then we deploy things in production via a feature store and MLOps pipeline. But we also have a development environment where we can just play around, find new models, experiment. And these will be, obviously this will work via continuous integration. So as we change things and test things, we can then test them and push them into production directly. So an agile way of working, not waiting until you've built a new product and then trying to push everything, but stepwise. Brings me to a point. Any questions so far? I can talk very quick, so very fast, so I just want to slow down a bit. Does anybody have a question? No? Okay, good.
I have some questions at the end as well.
Okay, yeah. There's questions at the end as well. I just wanted to give you a short break. Okay, so moving back to what I talked about earlier on. So if we look at the data science lifecycle and the problems we can have on the way, so referring to issues with data that we might encounter, or coding problems that occur as we build a project and do not apply best ways of working, up to deployment and then the issues we run into there. So if we now go through the pipeline that I proposed earlier on, how will this pipeline be able to manage those challenges that we've seen? So first of all, at MoneySuperMarket, we start with the data lake. Something that can be very helpful. So instead of already storing your data with SQL in a database, you just take the raw data and you just let it flow into a so-called lake where it could be any data format. It could be images, audio files, JSON format. It doesn't need to be accessible via SQL. So that makes it easier to gather loads of data from all sorts of different sources. Additionally, a data lake allows you to stream data, so read data in real time and move them forward more quicker to a BigQuery pipeline. And then you can go to a BigQuery database and you can decide to build some tables that you can utilize in a model in a more structured way. This helps you with access to data. So clearly now you improved access to data. Moving forward, we proposed to use DBT. It took us a while. So when you looked at the pipeline that I showed you, normally they would go, you extract data, you transform data, and you load data into your pipeline. So we changed this a bit now. We said, okay, we extract data, we load data, and then we transform them. So we use DBT to transform them. DBT is a data build tool. It's started in 2016 to be released. And one thing I like particularly about DBT, I mean, it can do great data transformation, and yeah, so it helps you to already clean your data in a way before you start working with them. What I like particularly about DBT is the data quality checks. So often you have another team will take care of your data, you read them into your pipeline, you run your model and your algorithm, you get the accuracy that you want, you move forward. The team that works elsewhere changes something, or the data change something, data flows change, the way they aggregate data changes, anything. Suddenly, your whole pipeline breaks down, and you don't know why. With DBT, you can run data quality checks beforehand. So these are generic tests, for example, so just testing, does, for example, here in this test, this is a number of orders. Okay, do these orders have all, is this unique values? Do they have null values? And do they have, and you can give a set of accepted values. So they need to either be orders that are placed, shipped, completed, returned. So if there's any manual errors in there, it will filter them out or will recognize early on that you have some issues with your data. That's not the only one. There's also, so this improves the data quality immediately. And you can automate it, obviously. So it's an automated way to see how your data quality looks like. The next thing is you can also use packages like db-utils or db-expectations. This is based on the Great Expectations package from Python. So the great thing here is, what I love about this one, is it will create documentation automatically. You write a test, and as you run the test, it creates a readable version of that test, which I think is great. So you cover something like documentation, which often falls low because there's business pressure and there's deadlines and people work at pace and suddenly they forget to document what they've done. And it becomes not reproducible at some point. And finally, the feature store. So we decided to go for with the Vertex AI feature store. So Vertex AI is a whole is a set of tools from Google now, where we said we will start using the feature store just because it makes it easier to monitor your data, to have the data all in one place. It's easy to share data between different teams. This is already clean data, so you don't have to do any, cleaning or any transformation. It's the data ready to use. They are linked to, for example, account ID, like a customer. You have a set of features that you can use then across teams that somebody who gets permission can access and utilize for their model building or for their analytics process. The feature store also obviously is storage, and it facilitates the serving of data, so when you run live. What I like particularly about the feature store, it has a version control, so it will keep a version of your features at a certain point in time. So if you make a mistake, or if something happens, if you store wrong data or anything, you can go back to the version before. So this is fantastic. So it facilitates. Sorry. Let me drink a sip of water. So it facilitates real-time analysis of your data and serving of your models. It enables monitoring, so it's easy to monitor if data are changing, if distributions of data are changing, and you need to be worried about your accuracy. I mentioned that it can track the versions of your feature store. So immediately now we're at a point where we're dealing with data leakage is being taken care of, and the time to run is improved. So the feature store, again, can use real-time data. And finally, the MLOps pipeline. So this helps you break away from having just a code monolith that you build in a notebook, or that just a chunk of code, a big code block. Because here it forces you to modularize your steps. So the way it works, you have different components. So these are just tiny components, and it gives you this nice graphical interface where you can create a little component. In that component, you have a code block, and those components will be something like, could be pre-processing of data, training data, evaluation of data, maybe have a condition in there. The evaluation, the accuracy needs to have a certain measure to go live into production, and then here the model serving or model deployment. But those are not set. You can build any kind of component. If your model needs more components, you can add another one. So it helps you to modularize your code and then implement tests to those modules. So each module will have an input and an output, very well defined. If you need to apply changes or work with another team, you can work on a single compartment of that code without affecting the other ones. So this will make an end-to-end deployment much, much easier. Oh gosh, apologies. So, hope it's not broken. Yeah. Okay, so if we go back to the challenges that I mentioned in the beginning. So we've now, with this last bit, we've now have the resource challenges, because this will make it easier to work cross-functional, across teams, because you work on single code blocks. You don't work on a big pipeline end-to-end. So you can focus on small pieces. It will help you to add tests. You have to add the tests yourself. It won't add them for you. And also the documentation, a lot of documentation you still might have to do yourself to it, but I think it has some functions for documentation. Did I miss anything? Yeah, so, and with that being said, so we are hoping, or we are aiming that this pipeline that we developed, that we now put together, we can host the different projects that we had. So whether it's, optimizing how you spend across different media, optimizing your ad spend, or whether you would like to, predict better products for customers. So all of those different projects, or work on your pricing investment, this pipeline will help you to build it at scale. So to use, big data sets, and work in relatively small teams, work cross-functional with other teams, help communicating across teams, and really maintain it for a long time. So have it running not just for a year or something, but for years in your business. So that being said, that's already, I have been a bit fast, I'm sorry, but I'm coming to an end here. So obviously this is my data science team. So you see it's some people, but it's not loads. So obviously we need all the help we can get from tools and from things that are out there that have been built already to support all the different projects we're delivering. And obviously thanks to the other data teams, I think what made all of this a bit easier as well is that we're a centralized data science team, so there's different, you can have different layouts in a business, how you want to structure your data science team. So we are centralized, that means we work alongside the data engineers, which makes it for us much, much easier because we have the same priorities, the same goals. So if we need a data engineer, we get easy access to a data engineer. It's not always given in a big company, so no, it's good ways of working. So a lot of thanks to the data engineers for helping us setting something up that can run for some time, hopefully. Thanks, and thank you.
Super. Thank you very much, Betty. Okay, we have some time for some questions. Does anyone have a question for Betty? Yes, John.
Okay. Hi there. Yeah, on your little cycle of where things could go wrong, you didn't put anything as a things can go horribly wrong here in the understanding the problem section, which, it doesn't really entirely conform with my experience.
Yeah, the whole, so understanding the business problem, I mentioned it could be a talk in its own. Because it's a whole series of how you engage with your stakeholders. It's obviously very dependent on the company you're working in, the size of the company, the understanding of your business partners, how technical are they, how well do they understand what is the issue. Often they come with questions and you have to listen for a while, understand how they work, and then suddenly you understand, oh, they should have asked another question. What they want is something completely different. So that's a massive part in the whole life cycle, yeah. And MLOps won't help you with that one.
Excellent. Yes, plenty that goes on there as well. Any other questions? Yes, the gentleman in the blue shirt. Do you want to? Marvellous, thank you. If you wait for the mic, thank you very much.
Yeah, thanks a lot. That was really interesting. It's Ben Follows from Government Operational Research Service. Really interested in the tools that you're using there, and you emphasised some of the features of monitoring the models over time. So I'm guessing that's kind of performance of the models, model characteristics and such like. Is the state of the art, are we up to the point of where the state of the art would allow you to feed back into another model rebuild automatically once, that performance dips below a particular threshold, for example? Are we into that bit where the model looks after itself, or are we still very much in your analysts are needing to sit on top, do the manual monitoring, press the button, set it off and ready to go?
So what I'm hoping with this pipeline, the monitoring will be automated so that we know when something is going wrong and we can go back and interfere, or we can, so ideally the way we saw it now, we would have a backup solution. If we see the monitoring drops or the accuracy drops below a certain threshold, we have a not as optimal solution in place that can jump in And then we have to go back and find, is it the model itself that's degraded? Is it the data that have drifted? Do we need to update things? I think what makes it all a lot easier is that you also have the monitoring of the features themselves in the feature store. So I've worked on a project recently where we had, where we saw the accuracy degrading, but then it took us forever to find out where in the data pipeline was the issue occurring and what was happening. So here you have not only the final monitoring of your accuracy and your model, but you also have the monitoring of the features themselves. So you can easily see, oh, did any of the underlying data change? Because obviously, often it's the data but that affects something. And then then you can check, is the data change, is it a mistake? Is it just an error? Or is it something that is actually happening? Like during the pandemic, a lot of the data were changing. So the old models didn't work anymore. They had to, they had to do something about it. So this will make it easier to then jump in and reintervene and build a new model, another model.
Excellent.
Yes, the lady there with the hand up. Sorry, I'm keeping you very busy there. Thank you. Just wait a second. And there it is. Marvelous. Thank you.
Thank you very much for a very interesting talk. My question is mostly about the feedback system. So how do you take care of the feedback in your ML models? Do you normally integrate those collected impacts from customers into your model in a real-time way, or how do you consider those feedbacks to improve the model's accuracy and things like that, to train your model? Because obviously you get some feedback at the end about the estimation accuracy that you make for your customers. So how you take care of them? You have built the model and it's working now, but imagine you're getting some feedback as the results of that.
So I hope I get this right, and feel free to talk to me after this session again. So there's obviously the accuracy of your model, which is often, it's informative for us data scientists. It might sometimes also be informative for the business, but then the business will have their own impact assessments, so their measurements, which might be engagement of a customer, or if you send an email there, how frequently is the unsubscription rate, and as you build that model, even if it's super accurate, or you think it's very accurate, it's fulfilling all the data science measurements, it might happen that you suddenly see loads of unsubscriptions. So then you need to obviously go back and say, something has gone wrong, even though we have a great model. Is it the way the way it was served, the way we spoke to the customer? Is it something that our model is not as accurate as we would hope? Have we fed a feature into the model that might not work with customers or might not help with customers? So so those things. So you will have a close relationship with the business partners, ideally with access to measurements to monitor their impact assessments as well. So while you have your accuracy running somewhere, at the same time I have a dashboard and analysis somewhere running, looking at what they are looking at and what's important to them, to then go back if I need to change something.
Thank you very much. I had a very quick question myself, Betty, if I may rather greedily take one. So I'm really interested in the feature store that you set up, and maybe picking up on the question that has already been asked about almost retraining, auto retraining, and looking at changes in the things that can go wrong. How aware is the company of the existence of the feature store, so that they know that if they change something downstream of that, it will have an impact, which in turn will impact all of this amazing tooling that you're putting in place? Is there a how do you elevate that awareness of the data streams and the pipelines coming into that store, so that people know, oh, I better talk to Betty's team before I mess around with this?
So thanks. So as I mentioned, the really nice thing is that we're now working closely with data engineering, which makes all of those much easier, because they are fully aware, whereas before there was a slight separation, so where people work on platform improvements or data improvements, they are not aware that there's data science models running on those tables, or there might be a disconnect sometimes. So I think this is resolved, because we have joint stand-ups that they are involved in what we're doing. At the same time, with the customers, it can be a challenge if you tell them, oh, I'm working on this fantastic feature store that will be great for me and for how I'm going to deploy this model, but it will postpone the time to delivery of an MVP. So at the same time, we promoted it during all hands calls with the product teams, where we said, you know, we're building, this is an internal tool. You don't see the output immediately, but, you know, to maintain a model in the long run, it's just super beneficial. It's state of the art. It's been developed. It came out last year. So we're doing something great for Money Supermarket and for, you know, the tools, the products that we have running. And yeah, so you get people, just raise awareness of what you're building and get people on board, and they understand, okay, this is all linked together. By the way, another feature which I love about dbt, I'm currently a big fan of dbt, only because we just discovered it a few months ago. You can link, so it will automatically link all your tables together. So while you're transforming your data and storing them somewhere, it will create all the relationships between your tables and visualize them, which makes it super easy to keep track of how will a change in this table affect something downstream elsewhere.
We have time for one more question, if there is one. But if not, we can... Yes, we have a question over there. Very convenient for the microphone. Marvellous.
Thanks. I'm just wondering, how do you choose which business problems are going to give you the most business value?
It can be challenging. At the moment, so we're trying to follow the strategies that the business had, which was you know, get more customers, but at the same time retain the customers that we have. So we focus a lot on, you know, customers. How can we get new customers on board with advertisement, but how can we at the same time maintain the customers that we have with the right recommendations or the right way of speaking to them? So this is all very much from the executive board prioritized. But there can often be a challenge of, you know, projects come on and we think they're interesting, but you know, there's a competition of we don't have the resource for everything. So what I'm trying to do, please bear in mind that I only just joined a few months ago. So what I'm trying to do is raise more awareness of how we're impacting the value of the business, the revenue that they're generating, or how we're saving costs. So find a way, how does what we are building in the data science team relate to what's going on in the end? That is around what I mentioned earlier, where, you know, we measure the accuracy and we say this is a great model, but then how does the business measure the impact of our model? They're not going to look at accuracy and say, oh, that's fine then. But they're going to look at how many customers are engaging with us, are responding to our emails, are clicking on our website, are staying with us on the website, how many customers will convert and, you know, drive revenue. So yeah, to link those to those, and, you know, to those measures, that's the important thing in the end. And that then determines which project is more important.
Fantastic.
Thank you.
Thank you very much, Betty, and thank you for your excellent questions. Betty, are you around for a few minutes afterwards?
Yeah, I'm around. And unfortunately, I have to go back to London tonight, but I will stay. I wanted to go to the women event as well.
Oh, great. Oh, fantastic. So we'll see you there. I just want to say then one last thank you to Betty for a lovely plenary. Thank you very much, Betty.
Thank you.